Welcome to section 3.3. We're going to be talking about the properties of logs. Now, keep in mind, log base A of B equals C can be written as A to the power of C equals B. Now, we have what's called the change of base formula, and that will allow us on our calculators to find the value of a log no matter what the base is. Now, the way we can write that for log base A of x, it's just the log, whatever base you want to use, of x over the log of base, whatever you want to use, of A. Now, we're more commonly going to be using the second version because our calculators have log base 10 built into them. Log base A of x is equal to the log of x over the log of A. And the same thing works with E. You can use the log base E of x, also known as the natural log of x, over the natural log of A. And that's change of base. So we can rewrite this using the change of base using our common log. Common log is log base 10. So it would be written as the log of 30 over the log of 4. And the log of 30 divided by the log of 4 is about 2.4534. For number 2, we would rewrite as the log of 14 over the log of 2. And that's going to be about 3.8074. And for the last one, log of 35 divided by the log of 7. That's going to be about 1.8271. Like I said, it also works with the natural log, log base E. So we could write this as the natural log of 30 over the natural log of 4. And you're going to get the same value as above, 2.4534. So for the next one, you would do natural log of 14 over the natural log of 2, and that's going to be about 3.8074. Log of 40, keep doing this, natural log of 40 over the natural log of 10, so you're going to get 1.6021, and then natural log of 25 over the natural log of 8. So that would give you about 1.5480. So that's the change of base formula. That allows us to calculate the values of the log on your calculators easily. So the different properties of logs. We have the product property. Log base A of u times v. Product property, we can split them up. They both get their own log with addition between. Also works for natural log. Quotient property, log base A of u divided by v. Division, you subtract the logs, the numerator minus the denominator. And then the power property of logs, log base A of u to the n. The exponent goes out to the front. It becomes n times the log base A of u. Keep that handy as we go over the next set of problems. So we can write these using natural log of 2 and the natural log of 3. So this is going to kind of help us work with the different values, and we can show that they're equivalent by calculating both. So we can find 6 by using just 2 and 3. Because 6 is the same as, so it would be the natural log of 2 times 3, because 2 times 3 is 6. So using our properties of logs, this would be the natural log of 2 plus the natural log of 3. That's another way to rewrite it. And if you type both of those into your calculator, you're going to find out they're equivalent. So that's showing you why that product property works. The natural log of 9. So only using 2 and 3, we can write as a natural log, and 9 is the same as 3 squared. So using our properties, this would become 2 times the natural log of 3. So that's how we can rewrite it using that power property. And then for the last one, it's the natural log of 2 over, and 27 is 3 to the third power. So what we have here, using that quotient property first, the natural log of 2 minus the natural log of 3 to the third. Now we have to use the power property as well. So it's the natural log of 2 minus 3 times the natural log of 3. That's rewritten. Once again, you can type those into your calculator and see that they are equivalent. That's the purpose of those problems. Now we're going to look at expanding using these properties. And when we expand, we always go quotient, product, and power in that order. So we want to look for number 11. I don't see any division, so the quotient property is unnecessary. Then we use the product property. Each of these factors gets their own log. The log base 4 of 5 plus the log base 4 of x cubed plus the log base 4 of y. Next, we look, are there any exponents? And there is for that middle one. So log base 4 of 5, leave as is, plus now it becomes 3 log base 4 of x plus the log base 4 of y. And we just expanded that expression. Now for number 12, it's log base 10. We don't need to write the 10. That's the common log. So we have here, we're going to use the product property first. There's no division, quotient doesn't apply. The log of 3 plus the log of x squared plus the log of y. Now look for those exponents. Log of 3 plus, it becomes 2 log of x plus the log of y. There is our expanded expression. Now for number 13, we have that square root. We need to rewrite this first. We can't work with the square root. We can't work in radical form. We want to change it to rational exponents. It's going to be the natural log, and in parentheses, 3x minus 5, and the square root is the same as raising to the 1/2 power over 7x. So now, we take care of the quotient property first. The natural log of the numerator, 3x minus 5 to the 1/2, minus the natural log of 7x. Now, there's a couple different ways to do this. I'll show you another way in the next step. So we have here, I want to use my product property first, so I have to apply it right here. The natural log of 3x minus 5 to the 1/2 minus, now in parentheses, the natural log of 7 minus the natural log of x. Plus, because it's quotient, it's product property. Now, if you notice, we have the grouping symbols there. We have to distribute that negative. Now I'm going to take care of my exponent first. 1/2, the natural log of 3x minus 5, minus the natural log of 7, minus the natural log of x. You can see the 7 and the x were both in the denominator. They both need to have a negative in front of them. Number 14 is very similar. The natural log, once again, rewrite 2x minus 3 to the 1/2 power over 8y. Now I find that using grouping symbols can get a little cumbersome. So what I do here, I'm going to use my quotient property. The natural log, 2x minus 3 to the 1/2. But now, looking at this, I see my 8 in the denominator and my y in the denominator. So natural log of 8, natural log of y. Since they're both in the denominator, I know automatically they both have a negative in front of them. It just saves a little bit of time, and to me it makes it a little bit easier to see. So just to clean it up, power property, 1/2 natural log of 2x minus 3 minus the natural log of 8 minus the natural log of y. As you get more comfortable with these, you can kind of start saving a few steps. You can almost get into the habit of, for some of the shorter ones, to do it all in almost one step. Now we have to use our quotient property first again. Log base 7 of 5x squared minus the log base 7 of y. There's only one term in the denominator, one factor in the denominator, so only one subtraction. Now we use the product, log base 7 of 5 plus the log base 7 of x squared minus the log base 7 of y. And now take care of the exponent, so it's log base 7 of 5 plus 2 log base 7 of x minus the log base 7 of y. And then our last one on this page. Use my quotient property. I have two factors in the denominator, so I'm at my natural log. X, let's take a step back. X cubed, y to the 1/2. Let's do that first. Over 2z to the 4th. Now, I'm going to condense a little bit here. I'm going to condense my steps. I know I'm using product property and quotient property. So I'm going to split up my numerator, the natural log of x cubed, plus the natural log of y to the 1/2. Minus, because the denominator, natural log of z, that's a 2, minus the natural log of z to the 4th. I knew my top factors had a plus in front, the bottom factors had a minus. And now I'll just take care of my exponents. 3 natural log of x plus 1/2 natural log of y minus the natural log of 2 minus 4 natural log of z. That's expanding. When you expand, you should have no exponents and all of your factors are separated. If it's in the numerator, it gets a plus. If it's in the denominator, it gets a minus. Keep that in mind. The more you do them, the easier they get. Now let's look at condensing. And condensing, we're going the opposite way. Everything's all split up. We're putting it all back together. So when we do this, we go the opposite. Power, then product, then quotient. So any coefficient becomes an exponent. So what I'm going to have is the log, I'm not even going to write the 10 because we don't need it, of x to the 1/2 plus the log of x plus 1 cubed. No more coefficients. Now, what we can do is, since it's addition, we use that product property. We put them together with 1 log x to the 1/2 times x plus 1 cubed. We're doing the opposite we just did. And x to the 1/2 we can write as the square root. So just to finish it up, log the square root of x times the quantity of x plus 1 cubed. That's expanded. Notice condensing. When we condense, we only have 1 log or 1 natural log in our answer. Number 18. The coefficient becomes our exponent. So it's the log base 2 of x plus 3 to the 4th. That's all we needed to do. That problem is finished. I'm going to go to number 20 first and then back to number 19. I'm going to take care of my coefficients first. So it becomes the natural log of x plus 2 squared minus the natural log of x minus the natural log of y cubed. Now, I only have one positive natural log. The other two are negatives. So now I want one natural log. Anything with a positive in front goes up top. So it's x plus 2 squared. If there's a negative in front, it goes in the denominator. So the x and the y cubed go in the denominator. And there is our final answer. 19 and 20 or 21 are a little bit trickier. I need to get rid of that coefficient. It's going to become our exponent. So it's going to be the log in parentheses, log base 2 of x plus the log base 2 of x plus 1, and that's all going to be raised to the 1/3 power. So now I'm going to use my product property with the addition inside, log base 2 of x times x plus 1. I put them together with multiplication, and it's still all being raised to the 1/3. Oops, sorry, not the log. So now, raising to the 1/3 is the same as the cube root. So it's the log base 2 of the cube root of x times x plus 1. And you can keep your answer just like that. And now number 21. See that 1/3, it's going to be our coefficient. So now, while I'm doing this, I'm going to condense on the inside. Natural log of x, actually, hold on, plus the natural log of x plus 4, x plus 3 to the 4th power, being raised to the 1/3, minus the natural log of x minus 1. So now I condense on the inside, natural log of x times x plus 3 to the 4th, minus the natural log of x minus 1. So now I have the natural log, using my quotient property, x times x plus 3 to the 4th, all of that being raised to the 1/3 over the x minus 1. So now to finish this up, I'm going to change the 1/3 to a cube root, so it's the natural log of the cube root of x times x plus 3 to the 4th divided by x minus 1. And there we have it. That's expanding, condensing, and using change of base to calculate logs. The more you expand and condense, the easier it gets. Some of them are a little bit more difficult than others, but it's practicing using those rules and working through it. Thank you, and I will see you in the next video.